Okay, so you need help on your complex numbers test. Here I have the practice test that I gave out once over Remind that you guys could practice beforehand. Instead of the actual test, because there are different versions of the actual test, I didn't want to do one version that might not be yours. So everybody's test I know is different than this one, but these are all the same questions, just with different numbers. Okay, so I'm going to go through these kind of one at a time. Hopefully it won't take too long. If I rush it a little bit, I apologize. But let's kind of get into it, okay? So the complex numbers test. Number one here. I want to zoom in actually, so I can see a little more here. All right. So number one, simplify the square root of negative 81. All right. Now the idea is technically it's impossible to take the square root of a negative number. If I try to type that in the calculator, it would give me an error message, which is no bueno. So how we approach these problems and the idea of complex numbers is the premise of an imaginary number, I. I is something that we use basically to make up some math so that we can actually solve problems with negative square roots. So I is equal to the square root of negative 1. Okay? That's what I is. That's the outcome. Now technically remember, the square root of negative 1 is not possible. It's not a real number because I can't take the square root of a negative. So again, that's why we call it imaginary. But we're going to call I the square root of negative 1. So what we're going to do here, the first one, is separate the square root of negative 1. Separate the negative from the number. Okay, so it's a negative 81, but I'm separating the negative from the actual 81. So I'll have the square root of negative 1, and then I'll have the square root of a positive 81. Okay? And now I'll simplify those two pieces. So the square root of negative 1, as we just mentioned, is what I'm going to call I. And the square root of 81, now that's a positive 81, is something I can actually do, right? 81 is a perfect square, which is nice. And the square root of 81 is actually just a 9. So at the end of this problem, I have I and 9, which makes 9I. That is my answer. Alright, so moving on, number 2. Number 2 is pretty much the same thing, but a little bit more complicated. Notice I have 5 here, okay? That's going to be important. Whatever number's out there, I'm going to have to multiply that at the very end. But let's focus on the square root of negative 28. So the first thing I want to do is separate my negative from my 28, just like I did in the previous problem. Okay? The square root of negative 1 is, again, what we call I. The 28, however, is not a perfect square. You remember our perfect squares, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, right? You keep that going, you get 25, 26, 49, etc. Right? 28 is not among those. It's not a perfect square. So we try to break it up into one of these perfect squares and then some other number. So 28, I could break it into 4 and 7 because 4 times 7 is 28 and 4 is a perfect square. I can't use numbers like 14 and 2 because 14 is not a perfect square and neither is 2, so that wouldn't help me at all. I have to make sure that one of these numbers is a perfect square and the 4 is. So this would become I still, that would just kind of bring down. The square root of 4, because it is a perfect square, right? It's a whole number, just a regular 2. And then the square root of 7 is the square root of 7. That's my remainder. I can't really change that. So I have here 2i square root of 7. But don't forget, I have to multiply my 5, because I have ignored that this whole time. I still have technically 5 times this, right? The 5 is technically sitting here the whole time, and now I have to actually use it. So at the very end, I have 5 times this 2i square root of 7, which is going to make a 10i square root of 7. So that's why my answer is A. Number 3. Here we're just trying to get the x by itself. So if I have x squared equal to negative 49, but I want to get the x by itself, okay, what's the opposite of squaring something? Because I need to get rid of my squaring here. I need to get rid of that exponent of 2. The opposite of squaring something is to square root something. So I'm going to square root both sides. That'll leave me with the x by itself. But now, of course, realize, hey, I've got the square root of negative 49. So just like the problems we've done right before this, separate the negative from the 49. Anytime you do the square root of a negative number, you have to separate that negative. So, just like before, by the way, this becomes a plus and minus, which is why you see those in the answer choices, because we'll have two answers technically here. X equals that plus minus. Now, square root of negative 1, remember, we call that I. Square root of 49, that's a perfect square, and it is just 7. So at the very end of this problem, I really have x equals positive negative 7i, which is B in this example. Number 4, same idea, same concept. We're just trying to get that x by itself. Okay, so I'm going to start by moving this forward team, so I'll subtract it. Then we'll have 2x squared equal to negative 72. Right, and then I can divide by 2. I'll have my x squared. I'll save the exponent for last. It'll be easier if I deal with the exponent last. So that's why I decided to divide by 2 in that last step. So we'll have x squared equal to negative 36. And then, like I said, the opposite of squaring something is the square root. So at the very end of this problem, I'll take the square root of both sides. That'll leave me with just x. And then, just like the previous 3 questions, we'll separate this negative from the number and simplify those 2 parts. So square root of negative 1, just like the previous 3 questions, is what we'll call I. And square root of 36 is perfect. It's just a 6. So at the end, we'll have that positive negative 6i will be our answer. So D. Number 5. I'm looking for point E. What is a complex number for point E? So point E, let me use blue here since these are already kind of red points. Point E is down here. And if I go to the real axis, right, which is the x-axis technically, right? If I go up to it, I'll be at 2, right? So my real number is 2. And then what's the imaginary number? On the imaginary axis, which is the y-axis, my E will be at negative 4i. Looks like negative 4i. So my number here is 2 minus 4i, which is answer choice B. If you scroll down, you can see it. B. Number 6 is a relatively easy question. It looks complicated, but it's easier than it seems. Basically, you have 2 complex numbers equal to each other. So let me give you just an example of 2 complex numbers that are equal to each other. So I'm just making this up, but if we had 4 plus 5i, it would be equal to 4 plus 5i. Well, I mean, that's pretty obvious, right? 4 plus 5i is equal to 4 plus 5i. Why wouldn't it? They're exactly the same. That's the premise of this problem. These are the same, these are equal to each other because the 4 is equal to the 4, and the 5 is equal to the 5, so those are the same. So in my problem, I have the 6x, and I need the 6x to be equal to a 12, right? I need those to be the same. So if 6x is supposed to be 12, then what is the x? 6 times what? Well, the x would be 2, right? Because 6 times 2 would make that 12. And I do the same thing for the I term. So this is a 36, and this is 9y. So 9 times something is supposed to be 36, right? Because these are both supposed to be 36. So 9 times 4 is 36, right? So y would equal 4. So my answer, D. All right. Move on up. Number 7, complex conjugate. So complex conjugate is just, all it is just changing the sign to the imaginary part. So the complex numbers are always made up of a real part, right? They're a plus bi. A, the real part, and bi, the imaginary part. Okay? So here's my real part, and here's my imaginary part. And the conjugate, again, is just changing the sign to the imaginary part. So my conjugate is negative 5 minus 8i. I don't change the sign to the real part, so negative 5 stays as negative 5. I only change the sign to the imaginary part. So that positive 8i is now going to be a negative 8i. So my answer would be A. Number 8, there's a formula. This is equal to the square root of a squared plus b squared. Now, this is my a. Remember, it's because it's a plus bi. So 2 is a, and 2 is also b. So I'm just going to plug them in. I'll have the square root of 2 squared plus 2 squared. Now, notice it's not 2i squared. I'm not using that. I'm just using the numbers. And now I'm just going to square them, and I'll add them together, and then I'll simplify the radical at the end if I have to. So this would be 4 plus 4, right, or the square root of 8. And that is actually something I can simplify. I can break that 8 up into 4 times 2. So the square root of 4 times the square root of 2. The square root of 4 is 2, and the square root of 2 is left as a remainder. So my answer would be C. All right, number 9, you're simplifying, you're just adding like terms. Since I'm adding here, there's really nothing I have to worry about. I just have to combine like terms. I'm not FOILing or anything because that's when I multiply, but this clearly says adding, so when I'm adding, I'm just putting together like terms. All right, so what are like terms? I have 13 and 7, right? So I'm adding 13 plus 7, which makes 20. And then what other like terms do I have? Well, I have negative 4i plus 12i. So negative 4i plus 12i would be 8i. So my answer would be 20 plus 8i. All right, just combine like terms. Do not multiply any of this because I'm not supposed to. It doesn't say to multiply, right? It says to add. So make sure you're following your instructions here. Now, number 10 says to subtract. So whenever I see a subtraction problem, one thing I like to do first, before I try to combine any of these terms, is distribute my negative, okay? This is a negative 2 and a negative 5i. A lot of people will forget to do that negative 5i because they won't remember to distribute that negative. So don't you forget that you're supposed to distribute that negative. So really this problem becomes 9i minus 2 minus 5i, right? And 9i can just kind of get brought down here. And then you combine your like terms, like anything else. 9i minus 5i makes negative 4i, and then the negative 2 can get brought down. So my answer is not on there, because apparently I wrote a 14. So, anywho, oh no, it's a positive 4. What am I thinking? Silly me. Because 9 minus 5 is 4. Okay, anyway. I digress. So I have 4i and negative 2, which is D. There we go. It's backwards, yes, but it's a negative 2 and it's a positive 4i, as I almost made that mistake. So my apologies, but it is there. 9 minus 5 is a positive 4, not a negative 4. I've been doing this, and I keep losing my mind. All right. Number 11. All right, so I have negative 15 times I to the 31st power. So what I'm going to have is negative 15 times something. I'm going to simplify my I to the 31st power. That's a trick to this problem. Now, this can be one of 4 things. This is either going to be I, negative 1, negative I, or positive 1. I'm going to be plugging in one of those values in these parentheses. Well, which one do I use? That's the question. Well, here's the reason, here's sort of the process. I to the first power is just I, of course, right? I to the second power is negative 1. I to the third power is negative I, and I to the fourth power is positive 1. So that's where these 4 terms are coming from. But if I try to go to I to the fifth power, I repeat my process and I start back at I again. I to the sixth power would be negative 1. I to the seventh power is going to be negative I, and I to the 8th power is a positive 1. So the cycle repeated itself. I had I, negative 1, negative I, and positive 1. And it's every four terms, it repeats. So here's my trick to doing this problem. I take my exponent, which is 31 in this case, and I divide it by 4. I'm dividing it by 4 because this starts over every 4 terms. Okay? If that number, whatever that number is, if it ends in 0.25, then it's the first term in the sequence, meaning the answer to that would be I. If it ends as 0.5, it's the second term in the sequence, which is negative 1. If it ends as 0.75, it's the third term in the sequence, which is negative I. And if it ends as a whole number, it's the fourth term in the sequence, which is 1. So 31 divided by 4, I believe, is 7.75. So because this ends in 0.75, that means it's negative I. So I'm plugging in negative I here, and I just put this together. Negative 15 times negative I, that's two negatives, makes us a positive 15 I. So my answer would be B. So yours is going to be kind of tricky. You just basically have to know which part of the sequence are you landing in. Your exponent, when you divided it by 4, if it ended in 0.25, then you're plugging in I. If it ended in 0.5, you're plugging in negative 1. If it did what I did, ended in 0.75, you're plugging in negative I. If it came out to be a whole number, then you'd be just plugging in 1. Okay? So, number 12. You're multiplying these. So now you're actually multiplying, right? You're foiling because you actually are multiplying. You're not adding them together. So you're going to distribute here. You're going to have to distribute 4 times 3, which would give me 12, and 4 times 6i, which would give me 24i, and then distribute 3i. 3i times 3 would be 9i, and then 3i times 6i would be 18i squared. Now that's the thing. Don't forget on yours as well that this I term times this I term combine to make an I squared term. Okay? Let me see if I can move this real quick. Yes, I can. Let me put this over here so it's not on the black part of the screen. Alright. Now the only thing that you have to really remember here is that I squared, we just talked about this a moment ago really, is equal to negative 1. So anytime you get that I squared, immediately change it to negative 1. Okay? You can either erase it on your paper or just write this whole thing down again and change it to a negative 1. So I'm just copying everything down, but I'm making sure that I've changed that I squared to negative 1. Which of course means this will be negative 18. And again, you can copy all this down again if you want to, or just erase it on your paper. So you don't copy down. But anyway, now you just combine your like terms. So these two terms are alike. 24 plus 9 makes 33i. And these two terms, 12 minus 18, are also alike. That's a negative 6. So I have negative 6 plus 33i is my answer. Alright, so yours, make sure you FOIL it. Make sure you change your I squared to negative 1s, and then combine your like terms. Now number 13. The idea of this problem is you have to multiply the top and bottom. You have to multiply the top and bottom by the conjugate of the bottom. So remember the conjugate we just mentioned up there, number 7 or 8? The conjugate, you just change the sign to the imaginary part. So the conjugate of 4 minus I is 4 plus I. So I'm multiplying the top and bottom by both 4 plus I. So I'm going to put these in parentheses because it helps me visualize things a little bit better. But I have to FOIL now, just like I did in the last problem. 2 times 4 would be 8. 2 times I would be 2I. 4I times 4 would be 16I. And then 4I times I would be 4I squared. Okay, again, don't forget about that I squared at the end. And the bottom, if you FOIL this out, 4 times 4 is 16. 4 times I is 4I. Negative I times 4 is negative 4I. And negative I times positive I is negative I squared. Again, one thing I want to do immediately is change these I squareds to negative 1. So if I just rewrite this whole thing down, I'll have 8 plus 2I plus 16I plus 4 times negative 1. And on the bottom, I've got 16 plus 4i, minus 4i. And the last part is minus. Now be careful, because that minus is already there, but I squared is negative 1. So technically I'm minusing negative 1. Now one thing, I'm not going to write this all out again, but 4 times, you can if you want to, 4 times negative 1 is just going to make this whole thing here a negative 4. So let me just go ahead and just change that to a negative 4. And on the bottom, a negative 1 is going to make that a positive 1. So let me go ahead and quickly just change that to a positive 1. And now let's just combine your like terms. So on the top, the 2i and the 16i will combine to make an 18i. And the 8 minus 4 would make a positive 4. So I'll have a 4 plus 18i. And on the bottom, the negative 4i minus 4i, those actually end up canceling each other out and being 0. And I get 16 plus 1, which is 17. And that would be my final answer. Okay? If by any chance you see on your answer that your 3 numbers can all be reduced, for instance, let's just pretend that this was a 16 for a minute. I would realize, hey, I could divide all of those numbers by 2. And I would divide all of those numbers by 2 to reduce my fraction. All right? That wasn't the case in my problem, but it might be the case in your problem if you realize that your final answer isn't one of the final answers. You might want to ask yourself, hey, are all these numbers divisible by something? And can I reduce that down? Because chances are that's probably the case. All right. And these problems are very similar to problems that we just covered in the multiple choice section. So on your paper, you have to keep in mind that there is a typo on this. This problem is actually 2x squared. And I think on all of them, it's missing that squared. So make sure you add that first and foremost. And just solve this problem like you did in number 3 or 4. So, I'm going to subtract my 29. I'll have 2x squared equal to, what is that? Negative 128. Dividing by 2, I'll have x squared equal to negative 64. And then I'll take the square root of the end. I'll have x equal to the square root of negative 64. Don't get the plus and minus. Again, you separate the negative from the 64, and this will become I and 8, so my answer would be positive negative 8i. Number 15, you're using that formula again. So you have that a squared plus b squared. Remember, this is your a value, this is your b value. You're not using the I, you're just using the numbers. So be careful, especially if you have negatives. Put parentheses on them. Negative 5 squared plus 2 squared. So this should become, again, this is where I saw a lot of mistakes, but your negative 5 squared is a positive 25. So this would be a 25 plus 4, because negative 5 squared is 25, 2 squared is 4, which when I add them together, I have the square root of 29. And that's my final answer, because I cannot simplify that. But if you can simplify your answer there, go ahead and do so. But I can't simplify that. Number 16. You're foiling again, so 4 times 4 is 16. 4 times negative 7i is negative 28i. 3i times 4 is 12i, and then 3i times negative 7i is negative 21i squared. So again, don't forget that the I squared is technically a negative 1. That's the main thing to remember here. Just copying everything down. I'm just going to erase it so I don't write it again, but negative 21 times a negative 1 is going to be a positive 21, so I'm just going to go ahead and change this to a positive 21. And then combine like terms. These two would combine to make negative 16i, and then 16 plus 21 would make, what would that be? 37? So maybe 37 minus 69. Hopefully I got that right. Now number 17. Same as number 13, I think, in a way. You multiply the top and bottom. Let me zoom in actually here a little bit. You multiply the top and bottom by the conjugate of the bottom. So what's the conjugate of negative I? Well, it's a positive I. So multiplying the top and bottom by a positive I. So 3 times I is going to make 3i. And 6 times I is going to make 6i squared. Again, don't forget about your I squared. On the bottom, a negative times a positive, this is going to become a negative I squared. Again, because I times I is I squared. So I want to quickly just go ahead and change the I squared to negative 1. That's the main thing you don't want to forget about. So the top would be 3i plus 6 times negative 1. The bottom, now this, be very careful, because yours is exactly the same as this. A negative I squared is a negative 1. So that negative's already there, but I squared is a negative 1, so you technically have two negatives going on. Alright, again, if you were to simplify this, we'll have 3i minus 6, right? And the bottom would be a positive 1. And anything divided by 1 is that same thing. So my answer is just 3i minus 6. Alright, folks, I hope that helped you with your test. Your questions are different, but it's exactly the same process that I just went through in all of these. Hopefully it helps a little bit. I'm talking really fast. I've been talking a lot. I'll see you in another video. Bye-bye.